Hello, my name is Derek Peterman. I represent Ophir Spiricon in Northern California, and I'm going to talk a little bit about beam attenuation with the CCD. Beam attenuation for a CCD is very important. The detector will saturate at about 1 microwatt per square centimeter. Most lasers have a power density of several orders of magnitude higher than 1 microwatt per square centimeter, so you'll immediately saturate the CCD without any form of beam attenuation. There's a couple different types of beam attenuation. One is a neutral density absorptive filter like this, which simply absorbs the light, works like a pair of sunglasses. The other way is using some sort of front surface reflection called an LBS 300. The reason why you might want to use one versus the other, if you have a very high amount of power in your laser beam and you shoot it into something that absorbs all that power, well, in one case, the glass can simply break. You're simply absorbing so much power that it just destroys the material, and it breaks the ND filter and also will eventually fry your camera, which you probably don't want to do. The other problem with absorptive neutral density filters is a little bit more insidious. You can shine the beam onto the neutral density filter. It absorbs the power, it warms up that material a little bit. The index of refraction of that material actually changes and creates a thermal lens and will distort the beam profile. So you don't want to do that either. So what you need to do is, for high power lasers, is use something which has a front surface reflection. So this is the LBS 300. I'll show you how it attaches to the camera. Just going to screw it on here. So if I had a laser here coming from the top, 96% of the light would go straight through. 4% would reflect from the front surface onto another wedge inside. Another 4% of that 4% would be deflected into the camera. But another good way to adjust the beam attenuation is also these sliders that we provide with the LBS 300. You can simply slide them in. They have a couple of different neutral density values on each side. And you can just simply slide this in to adjust the attenuation level. We can actually put as much as a couple kilowatts of power using this particular beam attenuator. Typically, you have to bring the beam down by a factor of, say, 1 billion to get a beam profile before you saturate the detector. A final way to adjust the beam attenuation, or at least the sensitivity of the camera, we do allow you to control the integration time of the camera. You can see as I move it back and forth. But what happens is you can see sort of a white area as I increase exposure time. What I'm doing is I'm basically the way this setting works is the camera, as charge builds up in each little pixel on the camera due to the light striking it, we wait a certain amount of time before we pull that charge off the camera. If I wait longer, what happens is more and more charge builds up, and eventually I saturate the pixel array. What I can do is I can reduce that time electronically such that charge is collected fast enough so it doesn't saturate that pixel array. So a final thing is, once you've adjusted your beam attenuation, you can actually change basically the sensitivity of the camera electronically to dial in the amount of light that you want. That's a little something about beam attenuation. If you have further questions, I'd be glad to take care of you, or your local rep or our service department would also be glad to talk with you. You can give us a call at 866-755-5499, or visit us on the web at www.ophirop.com/photonics.